Hi, in this video, I will be showing you how to invoke the testing and verification tool in the MATLAB code that we already have working. Right now, we have already working MATLAB loopback for oversampling equal to 8. We have adjusted the code according to antenna. The next part is integrating the tool in the code. After that, we will enable continuous transmission. And then the last part, I will demonstrate this OFDM code using antennas on the RFSoC. So first, to integrate the tool, I will need to open the SDK. Once I have this block diagram open, I will just export the hardware and then launch the SDK. These are the same steps that have been done in the earlier demonstration where we demonstrated how to integrate the tool in already working Xilinx reference example. To invoke the tool, I will copy the command line commands from SDK log and redirect them onto accessct.bat file, a Windows batch file for Xilinx XDK using a tickle script. Once the SDK opens, I will just run the code in debug mode. I will program the board, firstly reset the board and then program the board. Once that will be done, all the commands that were used by the SDK window will be displayed in the SDK log under accessdb commands. I will copy those commands and put it in a tickle file. Firstly, I'll let the SDK load its repositories and everything, and I'll wait for SDK to be ready. Now, once the SDK is ready, I'll firstly delete the duplicate debuggers and create a new debugger. Now, in this debugger, I will reset the system and program the FPGA. I will check in the application window that the project name is correct, and then I will debug. Now I am fast forwarding to the part where the debugging has been finished. The board is being programmed, and at this point, the debugging has been finished. Now, in this debugging window, I will open the SDK log window, and under the accessdb scripts, I have all the commands that were needed by SDK to program and reset the board. I'll just copy these commands and I will put it in a tickle script. Where you place the tickle script, the directory, it's up to you. I'm placing it in the directory that I've already been using, and I'll name the script as tutorial script. And then I'll be saving this text document as a tickle script. Now for this tickle script, firstly I will give the tickle script a path where the tickle script is situated that I can copy from here. And I can paste it in the tickle script. The addressing method is different in this tickle script, so I'll change the addressing. Now I've given the path to the tickle script. After this, in the end, I will just be writing this con command. Using this con command, you can connect to the board. After connecting, we will have to remember there is around a 27-second wait time before the board is ready to accept the data. So I'll give it 30 seconds wait time. After 30 seconds wait time, you'll need to open the address editor. In the address editor, you'll know where the DAC for where the BRAM for DAC is situated, where the BRAM for ADC is situated, where the GPIOs for DAC and ADC are situated. Now, the next part is to navigate to the folder where your file is situated, where you wrote the data. So to navigate to the folder where this file is situated, I'll just copy this path and I'll paste it in the tickle script. Again, the addressing method I'll change. Now the next part is to download the data from the bin file to the BRAM which is connected to DAC. For that, I will be using DOW command. These commands are given in the documentation portal for software development tool. Uh, this is the command that will download binary file onto the target address specified. So I will be using this command. I will be giving the file name from here. .bin, and I will give the address of the DAC which is present with the address of BRAM which is connected to DAC. So the address is, now once the file has been downloaded, I will switch on the transmitter. For that, I will use memory write command. Now I'll memory write on location for the GPIO for DAC, which is this location. And I will switch on the transmitter. Now I will turn on the receiver. For that, I will write on the memory location where the GPIO for ADC is situated. At this memory location, the GPIO for ADC is situated. At that location, I will write 1. Now I will wait for the reception to be complete. I'm giving an arbitrary time here. After this time, I will read the data from the VRAM onto a bin file. For that, I'll use memory read. This is the format for reading. The file type is bin file, and the file name in which it will write is, and the number of samples I want to read is these many, because there are 31,000 complex samples. So the real samples will be 62,000. Now the transaction has been completed. I can now switch off the receiver. To switch off the receiver, on the memory location where GPIO for ADC is present, I will write 0. And now this is the process completed. So now your tickle script is ready. Once your tickle script is ready, you just need to save as a tickle script. So I will save this script as a tickle script. And now when you check in the folder, I have a tutorial script as tickle script. I will delete the text document. I have a tickle script ready to invoke these commands in the batch file, which is present in the Xilinx subfolder at this path. This is the window batch file in which all the commands will be executed. So now to integrate this tool in MATLAB, I will firstly provide a path to the batch file, and then I will provide a path to the tickle script. I will redirect the tickle script onto the batch file using sprintf, in which we can specify the format in which two strings have to be redirected onto the other, and then using system command, where the command window is invoked, there I will invoke the sprintf function. So for that, here I am invoking the tool. I will be invoking the tool once I have written onto the file. After writing onto the file, then only my transmission has to take place. After transmission and reception has taken place, then we will read from the file. So testing and verification tool. Firstly, I will give the path to Windows batch file, xsct file path, bat file path. It is, I can copy it from here. xsct.bat. Then the tickle script path. My tickle script is present here. The name of the script is tutorial script. So I will specify that. The name of my script is tutorial script. I will copy the name and I will paste it here. This is path to the tickle script. Now the next point is to redirect the tickle script onto the bat file. So for that, I will use a sprintf function, and sprintf, in the way I will specify the format in which a string on which another string is being redirected. So here onto this file, the tickle script is being redirected. Now I will invoke the command line using system command. Using system function. So I will check whether it has been executed or not. Now I'll check if the tickle script has been executed. So if status is 0, that means the tickle script has been executed. So I can display tickle script has been executed successfully. Else, error message will be displayed that there was error in executing tickle script. And that's it. This way, the tool has been integrated. Now the next part is the file name that we gave in the tickle script. That is the file that we will have to read. So the file name was, this was the file name. So this is the file that we will be reading here. That is it. Now for one set of transmission, our code is ready with the tool. In the next part of the video, I will show you how to enable continuous transmission. Thank you.